The best way to represent covalent molecules is to draw Lewis electron dot structures. This is the game plan for drawing these structures correctly. I could go ahead and read this to you, but it's easier just to see it work through when we do several examples. So let's go ahead and get started. The only thing I want to remind you of is that you can determine the number of valence electrons in an atom by what family it's in on the periodic table. Anything in family 1 has 1 valence electron. Any atom in family 4 has 4 valence electrons. So just use the family that the atom is in to determine how many valence electrons it has. Let's go ahead and apply this game plan to some examples. Let's look at HCl. The first thing we have to do is determine the total number of valence electrons for all atoms. So if we look on our periodic table, we can see hydrogen is in family number 1. So we have 1 valence electron from the hydrogen. Chlorine is in family number 7. We have 7 valence electrons from chlorine. And if we add those together, we have 8 total electrons that we need to assign to our Lewis structure. So the next step then is to represent a pair of electrons with a bond from the central atom to the other atoms. The central atom is usually the first element listed in the formula, except for when the first element listed is hydrogen. So in this case, chlorine is actually our central atom. We're going to draw a bond from the chlorine to the hydrogen. That bond represents 2 electrons. 1 electron from hydrogen, 1 electron from chlorine. So we've assigned 2 electrons, and we still have 6 left to assign. We have to use those 6 to make sure all the atoms satisfy the octet or duet rule. Now, these 2 electrons that are assigned apply to both hydrogen and to chlorine. So right now, with just the bond, hydrogen is satisfied. It is following the duet rule. Chlorine, however, only has 2 electrons assigned to it. To fulfill the octet rule, it needs 6 more electrons. Well, thankfully, we have 6 more electrons to assign. So those 6 electrons simply go around the chlorine. And this is an acceptable Lewis structure for hydrochloric acid. Then we can label the bond, and this is a single bond. This is also a polar bond because it's 2 different atoms bonded together. And this is a covalent bond. We can see that because the red dot represents hydrogen's electron, and this black dot represents chlorine's electron. So each atom is sharing an electron to make the bond, so that is a covalent bond. You also need to just sketch the molecule, and that is just simply the structure of the molecule without the electrons around it. Now it is your turn to try one. Try to draw the Lewis structure for water. When you think you've gotten it, press play and see how you did. Once again, you should have had 8 valence electrons to assign. If you drew it correctly, it should look a little something like this. Both bonds are single, polar, covalent bonds. Let's try one that has a double bond. So O2, if we look up oxygen on the periodic table, it's in family 6. There are 2 oxygens in O2, so we have to take 2 times 6 to get 12 total valence electrons to assign to this molecule. So we're going to next draw a bond between the 2 atoms that shows electrons being shared. So a bond between 2 oxygens. If we look at this, we're like, oh, okay, each oxygen has 2 electrons right now, so each oxygen needs 6 more electrons. So let me just assign the rest of the electrons and give each oxygen atom 6 more electrons. And if you do that and you actually check your work, you're going to find out, you've done something wrong because you've assigned 14 electrons. Check this out. 2, 4, 6, 8, 10, 12, 14. You can't assign more electrons than you have. You only have 12 electrons to assign. That's all you can do. So when you need more electrons than you have to make a double bond. So to do that, you just remove a pair of electrons from both atoms and then draw a double bond in between. And if that still doesn't work, you can keep drawing for a triple bond. This will only need a double bond. Check this out. By doing that, each oxygen now fulfills the octet rule and you've assigned the correct number of electrons. Look, this oxygen has 2, 4, 6, 8 electrons, and this oxygen has 2, 4, 6, 8 electrons. It fulfills the octet rule. This bond that you see here is a double bond. It is nonpolar this time because the two atoms that are bonded together are the same atom. So they have equal electronegativities. This bond is a covalent bond because the electrons being shared come from both atoms. If we just drew this as a simple structure, ignoring the extra electrons, it would look like just two oxygens double bonded together. Your turn to try the next one. It's also going to have a double bond, or maybe two, or maybe a triple bond. All right, you try to figure it out. CO2. Pause the video, try it out. When you think you got it, press play. You should have come up with something like this. There's a double bond between carbon and both oxygens. I do want to point out here that you should not have made a triple bond, because if you look at my helpful hints here, oxygen can only form one or two bonds. It cannot form three bonds or a triple bond. So the only way to do this is to form two double bonds between carbon and both oxygens. Let's try out another one that actually could have a couple different valence structures to be correct. So N2O, if you look up nitrogen, it has 5 valence electrons. There are 2 of those, so we have 10 total electrons from nitrogen. Oxygen's in family 6, so it has 6 electrons. So we have 16 total electrons to assign. So let's start by drawing bonds from the central atom to the other atoms. Now in this case, nitrogen is the first atom listed. It is the central atom, and then it forms a bond to another nitrogen and an oxygen. This time I'm not going to draw the little electron dots in there in the bonds. I'm just going to show a pair of electrons with a dashed line. So we've assigned electrons with the bonds. Now we need to assign the rest of the electrons to satisfy the octet and duet rule. So if we've already assigned 4 electrons, that means we have 12 electrons left to assign. Now I always like to start on the central atom and make sure it fulfills the octet rule first. So the central nitrogen is missing 4 electrons. So I'm going to start by putting 4 electrons around that nitrogen. And then this oxygen and this nitrogen each need 6 more electrons. So hopefully you can see we're already going to run into trouble because I've already assigned 8 electrons. I only have 8 left to assign. I don't have 12 more electrons to assign. So we're going to run into some issues. But if I start here just assigning electrons, I'll put 6 around the oxygen, and then that way I only have 2 more electrons I can assign. So this nitrogen over here, I could only give 2 electrons. So when you're looking at this, you're like, okay, this oxygen fulfills the octet rule, this nitrogen fulfills the octet rule, but this one does not. And all atoms have to satisfy the octet rule. So you have to make a double bond or a triple bond. So start by making a double bond. So get rid of a pair of electrons off a couple of the atoms and draw a double bond in instead. So here you'll see, okay, this oxygen still fulfills the octet rule. This nitrogen has 2, 4, 6, 8 electrons around it. It's good. But this nitrogen still only has 6 electrons around it. We have to make another multiple bond. So you can make a triple bond between the 2 nitrogens. In this case, all the atoms satisfy the octet rule. If I'm going to label these bonds then, this bond here is a single bond. It is polar because it's 2 different atoms, and it would be covalent because each atom is sharing 1 electron to make that bond. The bond between the nitrogens is a triple bond. It is nonpolar because it's 2 nitrogens bonded together, 2 of the same atom, and it is also covalent because each nitrogen is giving up electrons to share. If you just sketch this, it would look like this. Now here's the thing. You could actually draw another Lewis structure that would be correct. You could draw something like this, where you have a double bond between the nitrogen and oxygen and a double bond between the 2 nitrogens. This also satisfies the octet rule for all the atoms. It is a perfectly acceptable Lewis structure. So sometimes when you draw these, there's more than one way to cut your grass. Time for you to try another one. Take a stab at SO2. When you think you've got it, press play to see how you did. This is the structure you should have came up with 18 electrons to assign. You got to make one double bond. The last thing I need to show you is how you draw a Lewis structure for an ion. So let's look at H3O plus ion. Hydrogen is in family 1. We have 3 hydrogens, so there are 3 valence electrons to assign. Oxygen is in family 6, 6 valence electrons to assign. And in this case, we have an ion, and it's a cation, which means we've lost an electron. To get a positive charge, you have to lose an electron. So from my total now, you'd think I have 9 electrons, but I have a +1 ion, so I have to subtract an electron. So we only have 8 electrons to assign to make this ion. Oxygen is the central atom, because hydrogen is never the central atom, so we're going to use a pair of electrons to show a bond between oxygen and 3 hydrogens. Now when we do that, we'll see that we have assigned 2, 4, 6 electrons. We only have 2 more that we can assign. So we have to fulfill the octet and duet rule to satisfy all the atoms. Well, the hydrogens are already satisfied. By making the bond, they have 2 electrons. They are following the duet rule. This oxygen still needs 2 more electrons. It only has 6 pairs of electrons around it now. So the 2 electrons that we have left will go around the oxygen, and we've drawn the Lewis structure for an ion. Almost. When you draw a Lewis structure for an ion, you have to put it in brackets with the charge of that ion outside of the brackets. So this is actually the Lewis structure for the ion. The bonds in this structure are all single bonds. They're all polar because 2 different atoms bonded together, and they are all covalent bonds. So the sketch would look something like this, just without those 2 electrons on the oxygen. Your last turn to try to draw an acceptable Lewis structure for PO4 3-. In this case, it's an anion, so you'll actually add 3 electrons on. Go ahead and try it out. Push play when you think you got it. Should have came up with something like this. So keep practicing drawing Lewis structures. The only way to get better at them is to practice them and to follow the game plan.